हेलो दोस्तों, बिगनर्स पॉइंट में आपका स्वागत है। और अभी हम कर रहे हैं इकोनॉमिक्स। अगर इससे पहले की चैप्टर नहीं देखे तो देख लेना, वरना फिर यहाँ से भी देख सकते हो। द आंसर टू दिस क्वेश्चन डिपेंड्स ऑन द आंसर टू द प्रीवियस क्वेश्चन। क्वेश्चन क्या है? व्हाट शुड बी द साइज ऑफ ईच क्लास। इससे पहले ये पूरा पढ़ चुके हैं हम। गिवन द range of the variable, we can determine the number of classes once we decide the class interval. Thus we find that these two decisions are interlinked. We cannot decide on one without deciding on the other. In example 4, we have the number of classes has 10 given the value of range has 100. The class intervals are automatically 10. Note that in the present context, we have chosen class intervals that are equal in magnitude. However, we could have chosen class intervals that are not of equal magnitude. In fact, in that case, the classes would have been of unequal width. How should we determine the class limits? Class limits should be definite and clearly stated. Generally, open-ended classes such as 70 or over or less than 100 are not desirable. The lower and upper class limits should be determined in such a manner that frequencies of each class tend to concentrate in the middle of the class intervals. Class intervals are of two types: inclusive class intervals. In this case, values equal to the lower and upper limits of a class are included in the frequency of that same class. Exclusive class intervals: in this case, an item equal to either the upper or the lower class limit is excluded from the frequency of that class. In the case of discrete variables, both exclusive and inclusive class intervals can be used. In the case of continuous variables, inclusive class intervals are used very often. Example: suppose we have data on marks obtained by students in a test and all the marks are in full numbers. Fractional marks are not allowed. Suppose the marks obtained by the students vary from 0 to 100. This is a case of a discrete variable since fractional marks are not allowed. In this case, if we are using equal sized class intervals and decide to have 10 class intervals, then the class intervals can take either of the following forms. Inclusive form of class intervals: 0 to 10, 11 to 20, 21 to 30, 91 to 100 ऐसे. Exclusive form of class intervals: 0 to 10 से लेकर 19 to 100. In the case of exclusive class intervals, we have to decide in advance what is to be done if we get a value equal to the value of a class limit. For example, we could decide that values such as 10, 30, etc. should be put into the class intervals 0 to 10 and 20 to 30 respectively. This can be called the case of lower limit excluded. Or else we could put the values 10, 30, etc. into the class intervals 0, 10 to 20, 30 to 40 respectively. This can be called the case of upper limit excluded. Example of continuous variable: suppose we have data on variables such as height centimeters or weight kilograms. This data is of the continuous type. In such cases, the class intervals may be defined in the following manner: 30 kg 39.999 kg, 40 kg 49.999 kg, 50 kg 59.999 kg. These class intervals are understood in the following manner: 30 kg and above and under 40 kg, 40 kg and above and under 50 kg, 50 kg and above and under 60 kg. Frequency distribution of incomes of 550 employees of the company. Income: number of employees 8 to 899, 50 number employees 9 to 999, 100 employees 1000 to 199, 200, 11,000 to 100, 11,000 नहीं 1100 टू 1199, 150 एम्प्लॉई, 1300 से 100 ही कितना होगा ये 10, टोटल कितने हो गए 550. Adjustment in class interval. A close observation of the inclusive method in table 3.4 would show that through the variable income is a continuous variable. No such continuity is maintained when the classes are made. We find gap or discontinuity जो भी देखा between the upper limit of a class and the lower limit of the next class. For example, between the upper limit of the first class 899 and the lower limit of the class 900, we find a gap of 1. Then, how do we ensure the continuity of the variable while classifying data? This is achieved by making an adjustment in the class interval. The adjustment is done in the following way. Find the difference between the lower limit of the second class and the upper limit of the first class. For example, in table 3.4, the lower limit of the second class is 900 and the upper limit of the first class is 899. The difference between them is 1, that is 900 minus 899 equals to 1. Divide the difference obtained in 1 by 2, that is 0.2. Subtract the value obtained in 2 from lower limit of all classes, lower class limit minus 0.5. Add the value obtained in 2 to upper limit of all classes, upper class limit plus 0.5. After the adjustment that restores continuity of data in the frequency distribution, the table 3.4 is modified into table 3.5. After the adjustment in class limits, the equality 1 that determines the value of class mark would be modified as the following: adjusted class mark, adjusted upper class limit plus adjusted lower class limit divided by 2. Frequency distribution of incomes of 550 employees of a company. Income 799.5 to 899.5. Number of employees 50. 899.5 to 999.5. Employees, number of employees 100. 999.5, 1099.5, 200. 1099.5 to 1000, 199.5, 150. 1199.5 to 1299.5, 40. 1299.5 to 1399.5, 10. Total कितना हो गया 550. How should we get the frequency for each class? In simple terms, frequency of an observation means how many times that observation occurs in the raw data. In our table 3.1, we observed that the value 40 occurs thrice, 0 and 10 occur only once, 49 occurs 5 times, and also on. Thus, the frequency of 40 is 3, 0 is 1, 10 is 1, 49 is 5, and so on. But when the data are grouped into classes, as an example 3, the class frequency refers to the number of values in a particular class. The counting of class frequency is done by tally marks against the particular class. Finding class frequency by tally marking. A tally, sign of this tally, is put against a class for each student whose marks are included in that class. For example, if the marks obtained by a student are 57, we put a tally against 50 to 60. If the marks are 71, a tally is put against the 70 to 80. If someone obtains 40 marks, a tally is put against the class 40 to 50. Table 3.6 shows the tally marking of marks of 100 students in mathematics from table 3.1. The counting of tally is made easier when 4 of them are put as 1, 2, 3, 4, and the fifth tally is placed across them as 1, 2, 3, 4 and cross. Tallies are then counted as group of 5. So if there are 16 tallies in a class, we put them 1, 2, 3, 4 or 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5 और ये कितना हो जाएगा 1. तो कितना हो गया 5, 5 और 5. How much? That is 16. For the sake of convenience. Thus, frequency in a class is equal to the number of tallies against that class. Loss of information. The classification of data as a frequency distribution has an inherent shortcoming. While it summarizes the raw data, making it concise and comprehensible, it does not show the details that are found in raw data. There is a loss of information in classifying raw data, through much is gained by summarizing it has the classified data. Once the data are grouped into classes, an individual observation has no significance in further statistical calculations. In example 4, the class 20 to 30 contains 6 observations: 25, 25, 20, 22, 25, and 28. So when these data are grouped as a class 20 to 30 in the frequency distribution, the latter provides only the number of records in that class, that is frequency 6, but not their actual values. All values in this class are assumed to be equal to the middle value of the class interval or class mark, that is 25. Further statistical calculations are based on only on values of class mark and not on the values of the observation in that class. This is true for other classes as well. Thus, the use of class mark instead of the actual values of the observations in statistical methods involves considerable loss of information. However, being able to make more sense of the raw data has shown more makes this up. Frequency distribution with unequal classes. By now, you are familiar with the frequency distributions of equal class intervals. You know how they are constructed out of raw data, but in some cases, frequency distributions with unequal class intervals are more appropriate. If you observe the frequency distribution of example 4 as in table 3.6, you will notice that most of the observations are concentrated in class 40 to 50, 50 to 60, and 60 to 70. Their respective frequencies are 21, 23, 19. It means that out of 100 students, 63, 21, 23, 19 students are concentrated in these classes. Thus, 63% are in the middle range of 40 to 70. The remaining 37% of data are in classes 0 to 10, 10 to 20, 20 to 30, 30 to 40, 70 to 80, 80 to 90, and 90 to 100. These classes are especially polluted with observations. Further, you will also notice that observations in these classes deviate more from their respective class marks than in comparison to those in other classes. But if classes are to be formed in such a way that class marks coincide as far as possible to a value around which the observation in class 10 to concentrate, then unequal class interval is more appropriate. Table 3.1 shows the same frequency distribution of table 3.6. 3.6 ये वाली टेबल है, ऑब्जर्वेशन 0 तो मतलब एक ही है, 10 to 20 ये ऐसे टैली मार्क करेंगे, फ्रीक्वेंसी 1, 8, क्लास मार्क 15 और 5 और 15. अब इसमें क्या है, 0 ऑब्जर्वेशन फ्रीक्वेंसी 1 है और इसके 5 हैं, 10 to 8 है, 15 है फ्रीक्वेंसी. ठीक है, तो 3.6 in terms of unequal classes. Each of the class 40 to 50, 50 to 60, 60 to 70 are split into two classes. 40 to 50 is divided into 40 to 45 and 45 to 50. The class 50 to 60 is divided into 50 to 55 and 55 to 60, and class 60 to 70 is divided into 60 to 65 and 65 to 70. The new classes 40 to 45, 45 to 50, 50 to 55, 55 to 60, 60 to 65 and 65 to 70 have class interval of 5. The other classes 0 to 10, 10 to 20, 20 to 30, 30 to 40, 70 to 80, 80 to 90 and 90 to 100 retain their old class interval of 10. The last column of this table shows the new values of class marks for these classes. Compare them with the old values of class marks in table 3.6. Notice that the observations in these classes deviated more from their old class mark values than their new class mark values. Thus, the new class mark values are more representative of data in these classes than the old values. Figure 3.2 shows the frequency curve of the disruption distribution in table 3.7. The class marks of the table are plotted on x-axis and the frequencies are plotted on y-axis. Frequency array. So far we have discussed the classification of data for a continuous variable using the example of percentage marks of 100 students in mathematics. For a discrete variable, the classification of its data is known as frequency array. Since a discrete variable takes values and not intermediate fractional values between two integral values, we have frequencies that correspond to each of its integral values. The example in table 3.8 illustrates a frequency array. 3.8 frequency array of the size of households. Size of household, number of households. 1 is 5 number, 2 15, 3 25. The variable size of the household is discrete variable that only takes integral values as shown in the table. Vibrate frequency distribution. Very often when we take a sample from a population, we collect more than one type of information from each element of the sample. For example, suppose we have taken sample of 20 companies from the list of companies based in a city. Suppose that we collect information on sales and expenditure on advertisements from each company. In this case, we have bivariate sample data. Such bivariate data can be summarized using a bivariate frequency distribution. A bivariate frequency distribution can be defined as the frequency distribution of two variables. Table 3.9 shows the frequency distribution of two variables, sales and advertisements expenditure in rupees lakhs of 20 companies. The values of sales are classed in different columns, and the values of advertisement expenditure are classed in different rows. Each cell shows the frequency of the corresponding row and column values. For example, there are 3 firms whose sales are between 135 and 145 lakh. Their advertisement expenditures are between 64 and rupees 66,000. The use of a bivariate distribution would be taken up in chapter 8 on correlation. अब आ जाते हैं कंक्लूजन. द डाटा कलेक्टेड फ्रॉम प्राइमरी एंड सेकेंडरी सोर्सेज आर रॉ और अनक्लासिफाइड. वंस द डाटा आर कलेक्टेड, द नेक्स्ट स्टेप इज टू क्लासिफाई देम फॉर फर्दर स्टैटिकल एनालिसिस. Classification brings order in the data. The chapter enables you to know how data can be classified through frequency distribution in a comprehensive manner. Once you know the technique of classification, it will be easy for you to construct a frequency distribution both for continuous and discrete variables. जैसे कि ये frequency distribution of sales in lakh rupees at advertisement expenditure and thousands of rupees 20 firms. ये हो जाएगा. इसके बाद आ जाते हैं recap. Classification brings order to raw data. A frequency distribution shows how the different values of a variable are distributed in different classes along with their corresponding class frequencies. Either the upper class limit or the lower class limit is excluded in the exclusive method. Both the upper and the lower class limits are included in the inclusive method. In a frequency distribution, further statistical calculations are based only on the class mark values instead of values of the observation. The classes should be formed in such a way that the class mark of each class comes as close as possible to a value around which the observations in a class tend to concentrate. ठीक है, और इसी के साथ ये चैप्टर तुम्हारा हो जाता है समाप्त. अब मिलेंगे अगले चैप्टर में.